which is a senior developer advocate for MongoDB, which will talk about practical. And we also have two more speakers, which is Derennes and Alexis Vialaret, which are both working for Artifact. Arthur is an engineering lead with 5 years of experience in computer vision, and Alexis is a data engineer, and he builds infrastructure, pipelines, and all sorts of data-centric software. And they will speak about data engineering and ML ops on GCP. Also, I want to thank the ServerlessDays for this meetup, and also Frédéric Barthollet and Adrien Blanc, which are both organizers of ServerlessDays Paris. And we have here all of the organizers for the ServerlessDays Paris. And also a warm thanks to Christopher, which is our technical backend engineer, which are in charge of the display now. So remember that we will try to do a 1 meetup a month with this kind of format. And at the end of the presentation, you will have a small form to have some feedbacks, and also a small URL which you will propose some sort of speak you want to talk about on the Serverless Day. And I think I already have all I want to say. So maybe we can start with Adrienne. Adrienne, you can talk now for particle patterns for durable function.
Thank you, Laurent. All right, so we have much to get through, so let's get started. Let's see. So I am going to assume that you have all been familiar with Azure Functions. Azure Functions, when we use them in our applications, have probably come about because of some conversations that may have looked like this. You're probably in the middle of your sprint planning, or you're conversing with your colleagues, and while you're talking about your platform, you say, oh, you know what, this particular piece or this particular action is probably a good candidate for a function. You start talking about some of the smaller pieces of code or functionality that you'd like to invoke, and you talk about things that you don't necessarily want the full-blown infrastructure. You don't want to pay for all of that. You really just need to run maybe 1, 2, or a very small chunk of code to run a specific action. And you want to have exactly one trigger to kickstart that function. And so that conversation may have been like, oh, I just need to do some whatever small event-based task here without provisioning resources. Oh, but I need to dynamically scale if I do need it to go through. And I only want to pay for the resources that I actually use. And with that, that's why we use Azure Functions, right? That's what they're made for. They're great for that. And they have been in use for quite some time now. So now you're probably thinking, if you are not familiar, well, what are durable functions? You might have heard of them before. Maybe you have even seen them, but have not used them yourself. And so I'd like to go over what they are and what kind of patterns you would see while using them and what they would be best for. So to start, durable functions are what I like to say is the code-first style of development. It's an imperative way, meaning we want to explicitly tell our program, this is what I want you to do, step by step. This is exactly what I would like you to do within each step. And if you have used Azure Logic apps before, they are similar and could be considered the UI-first equivalent to this code-first durable functions style of development. Another thing that makes them different from regular Azure Functions is that they are stateful. So Azure Functions, you've used them, and if you've ever needed to keep some sort of state, either between functions or even within that single one that you're using itself, you'll know that it's possible, but it's pretty difficult to do. There's a lot of overhead and a lot of extra code that you need to write. But Durable Functions, the library that extends Azure Functions, already has this built in for you. So this is what manages the state, this is what manages the checkpoints, and this is what manages the restarts for you if you start using it for what it is best for, which are long-running workflow orchestrations or anything that needs to keep state. And lastly, the biggest difference is that they are consolidated. So again, for example, if you are trying to implement a similar workflow in regular Azure Functions, you might have some code here, you might have some code there, some helper functions, etc. And here, specifically with Durable Functions, we have a nice single place to put that all. This is why I say that it is consolidated. And we will see where that is in a moment. So at a high-level overview, that's what Durable Functions are, right? But how does it actually do that? Well, it does so with the help of 4 different function types, and I'll talk to you about them now. The first one is called the client function. So as the name implies, and as you might be able to infer, this is how we kickstart the function. It's the entry point to our durable function. And this is what kickstarts the new orchestration instance. So this could be an endpoint that you call from the application. Most of the time, it is just an HTTP endpoint that starts it. Now, the client is just like a regular function, except it has a very special binding called the durable client output binding. And what this does is it allows us to trigger both orchestrator functions and entity functions, 2 of which I'll talk about in a moment. And it will also allow us to interact with the long-running orchestrations that we have set forth. So once we've kickstarted our orchestration, the next function type that we will see and use is something called the orchestrator function. Now, just as the name implies, the orchestrator function is what manages the execution of our workflow, and it also manages the state of the data between what is happening in our steps. It's also here that you define the order of steps that you'd like to do, and this is how you handle errors or exceptions in a single place. So earlier when I said things were consolidated, it's because of this particular function. You're able to do them, do all of that and consolidate all of those pieces in this particular function. And just like the orchestrator, it handles everything. It knows where everything is at a specific point. It knows what to do. It knows what to do if something goes wrong, and it can carry people back in if for whatever reason it has led astray. So at this point, we actually haven't done any work. We have the client function, which has kickstarted it. We know we want to create, start or instantiate a durable function, and now we actually instantiate an orchestrator function, which is our order of steps, letting the program know this is what we want to do. And at this point, again, there has no processing that has been done. None of the steps that we actually want to do have taken place. And so for that, we need a third type of function called the activity function. And again, these are just like regular functions, except these can only be triggered by something called an activity trigger. So you'll have the same types, like a blob storage trigger or a timer trigger, but these are particular to durable functions because they are only supposed to be triggered by an orchestrator function that's meant to keep this durable function isolated. Now, these activity functions, they can accept input parameters from the orchestrator function. So that's what we mean by stateful, saying you can pass data between these functions. But the greatest part about that is that if you need to do something further after this activity function, the orchestrator will be able to handle that and continue to pass it on where it needs to go. Now, the activity functions, these are best if these are single responsibility tasks. So this is where we do the work that we need to do. We calculate something, we extract data from somewhere, we get information from external sources. This is where the work is actually done. And at this point, these are the main three functions you will probably use and see when you do use durable functions. You'll always have a client, you'll always have an orchestrator, and you'll always have one or more activity functions. If, however, you do need to deal with stateful entities, there is a fourth type of function called the entity function. Now, these are used specifically to define the operations that are for reading and writing or updating small pieces of state of your stateful entity. And just like the activity trigger, these, the entity functions, can only be triggered by the entity trigger. So it's a little bit special, just like the activity trigger. And for these are what manage your state explicitly. And they might make a little bit more sense once we get to the last pattern in my talk here. So wonderful. We now know at a high level what they are and how they may be different from Azure Functions. We know what kind of function types actually make up the durable function, but we need to go a little bit further. We need to go one level deeper. And so what's happening under the hood? What goes on when we actually start off and kickstart an orchestration? Well, once we've started and made a call to a client function, and let's say we are at the first step of many steps in an orchestrator that we have just started, this is what happens. The orchestrator will task or queue a task and send it to the first step, the first activity function. And what's interesting is that at this point, the orchestrator now stops. For all intents and purposes, it is completed, or at least is done with the work that it has to do at this point, because it has scheduled that queue message to go out to the first activity function. Now, the activity function is now doing its job. It's calculating, it's getting information, it's doing whatever it needs to do. But once it is finished, the activity function will then serialize that result of whatever process has been done in the function, and it will send it back to the orchestrator. So at this point, the orchestrator is asleep. It's taking a break, right? Because it was finished and it's kind of paused right now. But once this result gets back to the orchestrator, it says, hey, wake up, we need to do some more work. There's a result here. And it awakens again. And so at this point, once it receives the result, that result is stored. And now a very interesting series of steps occur. The first is that the orchestrator is now going to reload the entire execution history of this particular instance, and it's going to start at the very first line. It's going to go to first line, and it's going to have to decide, do I go ahead and send another queue message to the first activity function, or do I continue? And how it decides that is, as it restarts from the first line, it will go and say, oh, I've already scheduled a task to go to this activity function. So it moves to the next step. When it goes to the next step, it says, oh, I've already received a result from this first activity function. So it will no longer schedule another queue message to go to that first activity function. It will move on to the next step in the workflow. And it's the same thing. Once it's now at the second point, it will say, oh, I have not actually scheduled anything to go out there yet. So that's how it knows to go and send another queue message out to that second activity function. And for as many steps as you have, as many activity functions that you call in your orchestrator, this process repeats. So as you think about this, it's very important to keep in mind that because we keep restarting at the very beginning, and because we almost rewind and replay every single time for every single activity function that we do, we have to keep in mind that we have to write our orchestrators in a very specific way because of this very characteristic. We have to write our orchestrators in a very deterministic way. So what I mean by deterministic is, if any of you are familiar with functional programming, it's similar to that definition. So deterministic means that when we run this orchestrator function, no matter how many times we run this, and with the same inputs that we have put in, it has to give us the same result every single time, no matter how many times we run this. And that makes sense with this rewind and replay logic we have seen, because it restarts every single time. If anything were to change in this replay of this orchestrator function, that is going to affect the ending result. So we need to do these orchestrators, we need to implement them in a very deterministic way. And so I thought, rather than list to you in a very boring way what Microsoft documentation shows as what's acceptable and what's not, I just made a single meme. So if anything, you can just remember this slide when you're creating orchestrators. And that's basically saying Baby Yoda, or the foundling, says, say no to anything that is basically not deterministic. So datetime.now, any type of random generations, UUID generations, GUID generations, numbers, anything random, any I/O processing, multi-threading, or async API calls, all of these have been deemed not safe and not deterministic to be able to put into an orchestrator function. Instead, if you have to use those types of things, you should offload them and place them into an activity functions where these deterministic constraints don't exist. So at the very least, the only thing I have seen that has been approved and safe for a deterministic orchestrator is to use current UTC datetime. And again, it is highly advised to use anything that is not deterministic, anything you're questioning, to put it into an activity function. So with that, we can finally get into the patterns. And there are 6 of these that have been described. And the first one is called function chaining. So you may be able to infer what this means, but it is sequential. It is where the output of one is the input of another. And that sounded very familiar to me, almost like the pipe operator. But for this particular pattern, I decided to do something a little bit different. To me, this pattern sounds very much like the process of creating lumpia. Lumpia is a Filipino dish. It is pretty much like a Filipino egg roll. And so each step that we have completed for creating lumpia can be considered a step that can be done in a functional chaining pattern. And so I'm going to show you what that could look like in code. So you'll see we have here my lumpia chain. And in the very big bottom here, we have my client function. So this would be where we would start, right? If we're having we need to create some lumpia, we would probably start. And so here is where we instantiate the new orchestrator, which is called the lumpia chain function. And this is where we would call from a client, possibly. And now we move up to our actual orchestrator. So in this orchestrator, you'll see that we can do a try-catch method here. And for each step of my function chain, I'm going to send an input out to very specific activity functions. And out of each activity function, the output of that is then going to be the input of the next one. So for example, the first one, I'm sending nothing. It's going to just be the plain ingredients of this lumpia. And if we go to our first activity function of scooping filling onto the wrapper, that's exactly what we're doing. Of course, I'm contriving it here, trying to programmatically implement lumpia here is best done in just a string. So at this point, I'm going to return a potential lumpia. And now this new output is going to be the input of my next step. My next step is to now fold and roll this lumpia. So if we go to the next activity function of folding and rolling, we're going to imagine that it is folding and rolling. And here I'm just taking a string method to replace the potential to rolled. And so you can see each step is similar, right? At the end of each step is the new state or a new kind of lumpia. And at the end of that, the output of that activity function has been used for the next one until we finally get to the last one, which is called fry that sucker. So at the very end here, our inputs would be some ready to go rolled sealed lumpia. And the last part that we would need to do is to fry them. And that is a very quick example of what a function chain might look like. Now, the next type of pattern that we can do is something called a fan-out, fan-in pattern. So you might already be familiar with what fanning out is, and that's when there are multiple functions that are executed in parallel. And now the difficult part about this pattern, at least if you try to implement them, I guess without durable functions, is the fanning in part. The combination, the knowing that after you have spread out all of this processing across multiple nodes, knowing that they all belong to each other and knowing which ones actually get combined. And so we can take the actual example I just showed you and apply that again. So let's say we have a Filipino party, and if any of you have been to anything like that, or any party, you'll know that for any particular type of food, you need to have more than maybe one tray. And specifically for lumpia, these are these little egg rolls. You'll need way more if you're going to have a Filipino party. So what better way than to create more lumpia by finding more people to help create more lumpia? So for this example, I like to think of all of my aunts, which are called titas in Tagalog. And it's the same thing. I can fan out, I can get all of my titas, all of my aunts, and have them help me make more lumpia. So we can now take this processing, these sequence of steps, and have each of them do it. And at the end, we should result in more lumpia. So what does that look like in code? So again, we will take another look at what this looks like, this pattern. And same thing, we have a client function that we'll call. We know we're going to have a party, so we might instantiate the lumpia fan in, fan out orchestrator function we have here. And if we take a look at our orchestrator function, you'll see that, again, the fanning out part is fairly simple. Even in regular functions, we can do that no problem. It's the part of combining them is what's quite difficult to do. But with durable functions, because we are keeping our state here and it manages state for us, it's very simple to be able to just wait for all of those tasks to complete. So here I have a bunch of tasks. I have all of my aunts, all of my titas, which of course at this point I'm just sending back a simple list of all of my titas. And for each one, we are logically, as we would see it in person, I'm divvying up or separating out the work among all of my aunts. And for each one, I'm asking them, hey, can you make lots of lumpia? And of course, programmatically, what I'm showing is I'm just choosing a random number between 1 and 100, and that's the total that each of my aunts have made. And once they have all been completed, some are faster, some are slower, but they're all working at the same time. We will then just combine the total number of lumpias they have made and fry them all together. So if we actually ran this, I want to show you some things that are very helpful when you are working with durable functions. So it's starting here a little bit, make this a little larger. So you'll see here, these are the rest of my activity functions here, but these are the endpoints that we have. And the one I'm going to call is this one, the make more lumpia. So if I go over to my new tab, I already have this ready. So I'm going to call the make more lumpia function here. And what you'll see here is you'll see here that it is executed. And this is great if you are familiar with what you're doing, you just need to see a quick log. So this is one place to check out that everything has been completed successfully. But another place that is very helpful to see, here I'm using the Azure Storage Explorer to actually view the steps that have been taken. So I'm going to refresh this, and you'll see that this now has those steps that I talked about earlier when we spoke about how it was working under the hood. So you'll see execution has started on our orchestrator function here, which is lumpia fan in, fan out. Oops. And then you'll see here the orchestrator started. The task has been scheduled for that first step, which was to find all of my aunts. And you'll see here, the orchestrator completed, that's when it actually stops. This is when no work is being processed. Here is where the task, at least the first one of finding all of my aunts, has completed. And you'll see once it has returned the result, it has gone back to the orchestrator and has woken it up again because it has now received some more work to do. And for this particular one, you'll see make lots of lumpia has correctly been called 4 times. and the tasks have been completed. At the same time, these are all the lumpias that have been made. And finally, at the very end of this workflow, we see that we have a total of 184 deliciously fried lumpia ready to eat. But this is a very, very great way to debug, to see what is going on, to see each of the events in sequence happening. And it's very important to note that this is a great way that Durable Functions keeps the state or its data integrity intact, because it is using an event sourcing pattern, meaning everything that you see here is append only. Nothing is ever changed. It is always just added as another row to the end of this table. So I'm going to select all of this and delete it, because we are going to be running one more and I don't want to get confused. And so that would be fan out, fan in, right? Which is made much more simple with the durable functions. And at the very end, we could fry them all together. So that's fan out, fan in. The next one is async HTTP API. That's a big mouthful. But this one is very similar. It's known as the polling consumer pattern. And what is special about this is that sometimes you have very, very long running workflows, and you'd like to be able to give the client the ability to check on the status of something. And I don't know about you, but this sounded very familiar very recently. Something that takes a very, very long time, something you're aching to find out. And in particular, for us here in the US, I'm based in Nevada, actually. And so maybe you were also just as worried about what the Nevada ballot count was. So that seemed to be taking forever. And so in the same way, let's actually kickstart this one. Let's double check what the name was. I believe it was the same. Yes, begin Nevada count. So we're going to start this one. And so here, you'll see here, you've seen these already in the earlier ones, that you have built-in webhooks that are exposed to the client. And this is all from the Durable Functions library. So if we wanted to check, let's say we've begun the Nevada count and we're checking, and at the first step that we check, oh, it's still too early. So at this point, just to show you, the activity function I'm calling, I am just simulating a really long delay so that we're able to see and check the status of this, right? So as everybody was doing, as I was doing all last week because I could not focus on work, we were checking. We're always checking the status. Oh, we're still counting. And we're continuing to check. We're continuing to wait. Everybody is waiting. At this point, we're only having 67% of counties so far. And towards the very end is what seemed like they kept telling us, we'll be done, even though the final output of this is they're not finished counting. It's only 99%. There's some random amount that's still left to do. But for this particular pattern, this is, funnily enough, the first thing that came to mind when trying to explain and visually show what this pattern could look like. And so this is very helpful to be able to have these exposed right away. This is something that you don't have to take care of because the library takes care of it for you. And so I'm going to end this. And if we take a look at our storage, you'll see the same thing, right? You'll see when the execution has started. You'll see the task that has scheduled. You'll see for every time that that activity function has been called, you'll see the result. So again, this is a very nice place. You can also check the checkpoints if you do happen to use those. This is a very good way to debug and to see what is actually happening sequentially. All right, so let's go ahead, and I already ended those. And so that is the HTTP async HTTP API pattern. Now, the next pattern is something called the monitor pattern. So this one is a mirror almost of the async HTTP API pattern. And this, instead of querying and having the client ask for the status, you leave this to the orchestration. And preferably, you do this at regular intervals. So something that's very common with this is a weather checking app, or wanting to alert you if you are checking for a nice day, maybe to get an alert for when there is a sunny day. And so in code, very quickly, The bulk of what is important here is you will see that you will get an input here. In this case, I did not apply this because the weather API apparently has expired, or you have to have your own weather forecasting station to get an API key. So I have simplified this somewhat. So it basically gets the location of where you are, as well as your phone number. And this is what's important. You set an end time for when this monitoring should stop. And what this does is, now that while you're checking, you're either checking for if your conditions are good. So if it is sunny, then send a message to the phone, send a good weather alert. Otherwise, add another check at the next 30 minutes, at that next interval. And what's great about this token here, this end time, is at the very end of this monitoring, it's either going to stop once a text message has been sent or once the full timer has run out. And this repo will be available. I know I've gone through very quickly for the sake of time, but in the end, at the high level, that is what's happening here for the monitor pattern. So that's the monitor pattern. Next one's human interaction. This one is something I know, or I hope we all have already been familiar with, and that's the human interaction pattern. So for all the workflows that we have, everything that we've automated so far, shockingly, there are still a few that actually do still need human intervention. So we need some actual human decision before we can move on with our workflow. That's our two-factor or multi-factor authentication. That's an approval whenever we have a pull request. These are all actual great use cases to use the human interaction pattern, and one that is very much often used with durable functions. And lastly, the last pattern is the aggregator pattern. So this is great for when you need to use stateful entities. So if you're collecting data over a long period of time, or you're collecting data from several different kinds of sources and need to aggregate them into a single entity, this is the pattern to use. So with all the different places that we would have to do this, this is a great place to use stateful entities. And very quickly, I know I'm a little over time, but one great way to do this, I know a lot of us are excited about pre-ordering or actually receiving the new consoles, next-gen consoles. And so I've given this example of the aggregator pattern with ordering consoles. And the most important thing you need to know is that this is pretty much all you would need for a very simple one, of course. But the important thing here to know is that because of the durable entity client here, this durable client binding, what is great is that as orders are coming in for the pre-orders for the consoles, this can actually check right away. It will read the entity, it will read our single state of how many consoles we have left, and it can already tell you immediately if we actually still have it, and if we have any more consoles or not, then unfortunately we'll tell you all consoles are sold out. Otherwise, we would do something called the signal entity async, which then continues on with the process to place that pre-order. And so again, these are all available in the repo. And I will be happy to answer any questions that I didn't get through. But these are the 6 patterns that I have. So it's the function chaining, input of one is the output of the output of one is the input of another, fanning out, fanning in. So that's placing it all to all nodes, and then finally combining at the end. The async HTTP API pattern, which allows the client to check on the status of something. The monitor pattern, which lets the orchestration do that for you at regular intervals. The human interaction pattern, which is your two-factor authentication, your approval on our PRs, and finally the aggregator pattern, which is mostly used with our stateful entities. And with that, merci beaucoup, ServerlessDays Paris. Thank you so much.
Thank you so much again. I just want to remind that at the end of the second talk, we will have a panel discussion. So really feel free to prepare some questions for Adrienne. So it will be the opportunity during the panel discussion to address these questions with Adrienne. So do not hesitate to send it on the YouTube channel you are currently following. Thank you. Now we're moving to the next discussion. We'll now have a presentation about data engineering and MLOps and GCP. So the topic is how leveraging Google Cloud Platform serverless capabilities enabled Google to build a reliable, scalable, and secure data engineering and MLOps architecture for our client. This talk is presented by Arthur Derennes, which is engineering leader at Artefact, and Alexis Vialaret, which is data engineer at Artefact as well. So, guys, floor is yours.
Thank you. I'm just going to cast my screen.
Yep. Thanks a lot. Thanks a lot, Adrien. So I'm. Yeah, you do. Okay. So hi everyone. Thanks a lot for watching, and thank you, ServerlessDays Paris, for having us. So this talk will be quite English accent and of the talk itself. We're going to take a more of a bird's eye view of a data engineering project. So just a few words for this talk will be focusing on what we've done for our client at L'Oréal on GCP, so Google Cloud Platform, to some details of the services we use, and a quick word about Artefact. We are a consulting firm dedicated to data and helping clients build books and systems around data and leveraging the value around data. So could it be with machine learning, data science, data visualization, and data engineering? So I was going quite well, so I think we can move on to the third slide. So the idea of the talk is quite simple, because of the topic of the meetup, we went full retard on the naming. So first of all, we're going to talk about why serverless. So what are the for which you're going to want to have an architecture that is based on serverless services. And then we're going to show you, or at least present you how we've done it. So could you skip the slide, please?
Arthur, sorry to interrupt you. Your audio quality is not good. I would recommend to turn off the camera to see if it's better.
It's going to be okay. So can you hear me better? Let's roll with that. So the project we're going to present is will be referred as to demand sensing. So it is basically a demand forecasting project. So it's quite heavy on machine learning, and so that's why we're going to present the both aspects. But this project is quite a complex supply chain oriented project, which has many facets. There we we face the three challenges every. So first of all, performance. So we need good performance for our services, and especially our machine learning services, because good demand forecasting will lead to optimizing the supply chain by reducing obsoletes and limiting shortages. So obsoletes are products you haven't sold, and shortages are products the stock at the time of the sale. The second, data-enabled demand forecasting. There is a huge influence of the automation is around scalability, because as you know, L'Oréal is quite a huge company. It is global, and then we need to have a tool that is ready to be rolled out globally. So next.
Arthur, if you're okay with this, I'm going to
ensure that
Arthur, can you hear me? Thank you. I'm going to take over. I'm very sorry for these technical difficulties. So Arthur was, as Arthur was saying, we have a complex engineering context and also a complex business context, which is challenging, which is what we like. So first of all, on the data sides of things, data is pretty decentralized at L'Oréal. So we are going to address this challenge. Another challenge we face is that knowledge is also pretty decentralized. So we did a lot of work to reconciliate and to source all of this knowledge to centralize it. Data governance at L'Oréal, which is a whole work and a whole project of documentation and business practices around best practice with data is budding at L'Oréal. So we are also here to help develop it. And the business needs evolve very fast because we are building multiple things in parallel. So we have to be able to adapt quickly. On the engineering sides of things, the timeline is challenging. So we have to find ways to deliver quickly. We also need to quickly adapt to new requirements as they arise. Sorry, such as security constraints, which come up sometimes, and we also have a big no-ops constraint. So we want to minimize the amount of operational maintenance to our system. So that's right. No ops means no Kubernetes, which is a big challenge in and of itself, because Kubernetes is a cornerstone of a lot of web application, of a lot of data processing application, and we have to build our whole product without Kubernetes. So this is one of our most important challenges. So to address this challenge, first of all, about the data. So this is what I listed just earlier. And our vision is to, first of all, centralize all of this sparse data into our data platform, our data warehouse. We need also to be able to increase the quality of this data through tests, qualification, and validation with business analysts. we are going to help the data quality and data governance efforts with documentation, thorough documentation of interfaces and the transformation to put on the data. And we are also going to implement our best MLOps practices to allow quick and to allow quick model industrialization. In terms of engineering, our vision is to produce as much evolutive software as possible. So we are going to achieve this by using a modular architecture and loosely coupled services. So in case we need to change a particular block of a services, we are going to be able to as painlessly as possible. We are going to maximize the use of SaaS and FaaS and PaaS products from the Google Cloud Platform, which is going to increase our maintainability and reduce operational requirements. And lastly, we are going to be able to comply with all of the security needs by leveraging AIP, so it's Identity Aware Proxy, which is the main authentication gateway on the Google Cloud Platform, and also coupling it with the already existing at L'Oréal Azure Active Directory. So both of these products are going to allow us to identify and authorize people, and to identify and authorize services. We're going to be using service accounts and always following least privilege and globally best security practices. So following these requirements, we decided that serverless would make the most sense as it provides no ops. So this is one of the main requirements for reducing operational costs. We are also, it also provides a lot of evolutivity, notably on the Google Cloud Platform. New features arrive really quickly, and it's actually quite impressive the rate at which Google is able to churn out new cool features. It also allows us to build robust applications, mostly because of the ability to scale that is almost built in all of the serverless bricks that we are going to use, and also security by design. So we are deferring a lot of the security issues to Google. So as long as we manage properly our service accounts and people authorization, our applications are going to be safe. So this is why we are going serverless. Now, how are we going to do it? I'm going to deep dive a little more into this aspect. So this is our high-level design. We are going to be using some microservices to implement all of our business needs. So first of all, which is, that is outside our infrastructure is L'Oréal, of course, already existing IT. So there are lots of systems and databases and products that we are going to have to integrate with our solution. And now what we are going to build is, first of all, a data platform, which is going to include a data lake, pipelines, a data warehouse, and data marts. So all of the good data stuff. We are also going to provide a machine learning framework for our data scientists to use and train, version, and serve model in. And then what's going to be exposed to our business clients is going to be some dashboards, which are going to be using Looker, and also leverage a single sign-on that is going to increase our security, and a web app which is specific to our use case. It's called the Launch Setter, and also it's going to have a front end secured by a single sign-on. This is going to leverage all of the data from the data platform and the models from the machine learning framework. I'm going to zoom a little bit deeper into the data platform first, and then the machine learning framework and the web app use case. But first of all, what is our stack to achieve all of this. So for those of you who are less familiar with the GCP environment, these are all services that are provided by this cloud. I'm going to just give you a one-liner to what the tech is and how we use it. So first of all, Cloud SQL is simply just a managed SQL database, which we are going to use to store some logs and some parameters. Cloud storage is just a blob storage, so it's really multi-purpose and super versatile. We are going to use BigQuery as our data warehouse. It's a super powerful SaaS data analytics database, basically, a product. For our compute, we are going to serve our web apps and our web apps on App Engine. We are going to use Cloud Functions to do some small processing, some data transfer loads, which are going to be really light. We are going to use Cloud Build to train models, and we are going to use Cloud Run to serve them. Cloud Run and Cloud Function require events to be triggered, which are going to be provided by our scheduler. So we're just going to use Cloud Scheduler, which is basically a cron tab on your GCP project. And then we are going to use Cloud Composer, which is a managed Airflow to orchestrate and run jobs. Lastly, for security, I talked about it a little bit earlier, but we are going to be using identity-aware proxy to be able to authenticate and authorize people to access the various applications that we are going to expose. So first of all, how did we design our data warehouse? So first, so from left to right, we are going to have our data sources, which again come from the various IT sources that L'Oréal has. So we are going to be ingesting Excel files, CSV flat files, and we are going to be requesting REST endpoints to feed our data platform. They will all go to a landing zone where there's going to be some pre-processing and some archival done to this data. And then we are going to reach our data warehouse where all the magic happens. So we chose to split our data warehouse into technical layers and not business layers. So basically, instead of saying I want one pipeline for data type A, one pipeline for data type B, etc., we are instead going to divide our data warehouse into a staging layer, which is going to be a table where the data is going to be as close as possible to the input source. So for example, if you are going to ingest a CSV file, the table is going to be basically the CSV file, but in BigQuery. Minimal transformation are done at this point. We are then going to output a work tables in a work data set. So for each data type, we are going to have a table in the work data set that's going to be a view of the data at a certain date. That's going to be used to store all of the transformation we are going to do and all of basically the intermediate processing steps that we are going to apply on this data. In parallel, we also have a history table, which is going to store and version all of the data. So for example, if we want to retrain a model on some past data, we are going to use this history table to build a data set that's going to bring us back into the past of our data. So basically, think of it like a versioning tool for our data. Once all of our transformation on this incoming data is done, we are going to have a final data set, which is going to conform to a set of conventions about types, about naming, about basically everything that we can convention about incoming data. So all of the data will converge to this data set. And then from this data model, we are going to be able to build extracts, so data marts basically, for our specific clients. So we have multiple data clients that we need a particular subset of our final data set to work. So we are going to provide them in this export data set. This data is then going naturally to a departure zone. So it's either going to be buckets for tools that are going to require flat files, or simply views or data marts in BigQuery. In parallel of all of this, we also have our operational stack, so Cloud Composer for, as I said earlier, orchestrating all of this. I'm sorry, we don't have nice orchestrating GIFs as Adrienne presented earlier, but Composer will have to do. And we use Stackdriver monitoring and logging for, logging, monitoring, and alerting, which allows us to monitor everything that's going on in this data warehouse. So this is really the beating heart of the system. So of course we need to document everything that we do, and this is just an example of the type of documentation we are outputting. I've had to anonymize each of the labels, but you have to imagine that each of these icons is a table that data comes in and out of, and reaches the end of our data warehouse in the export data set. So basically data comes in, data is transformed, and data comes out the other side. So what development choice did we do to allow us to have consistent documentation with the actual reality of our data platform? So first of all, we decided that the source code would be the single source of truth for basically everything that's going on in this project, from documentation to infrastructure to code and pipelines. So basically the data models in BigQuery are really simple. It's just a JSON file which you give the name of the table, the name of the column, the type, and a description. And you don't have primary keys, you don't have constraints, etc. So that makes things really easy. Having our source of truth in the source code allows us to have a high degree of automation thanks to continuous delivery pipelines. This is really a big one because it allows us to really have a documentation that match what's actually deployed with the least amount of effort. And also this allows us to integrate MLOps from the get-go. So as Arthur and myself stated since the beginning of this talk, MLOps is really big for us, and we have to integrate it from the beginning. So from our source code, our infrastructure is going to be built thanks to Terraform. So tables, datasets, buckets, cloud functions, composer jobs, etc. Our documentation is going to also be generated from code. So this allows us to have documentation that matches the data models that we have in code, the data table specifications. And this outputs docs for tech and non-tech people. So this is really something we strive for, and it's going on Confluence. Pipelines are also generated automatically. So we have DAGs that are directed acyclic graphs, which are the primary Airflow model that are automatically generated and incorporate configuration tests. Also Great Expectations, which is a nice tool to have to validate data quality. We focused a lot on MLOps. So this is how data scientists work with us. So they are going to build models and to build from code. So we are using GitLab for the moment, and this is going to trigger some cloud build jobs, which are going to train the models from, as you can see, the Launchletter data mart, which is our product stored in BigQuery and the output of our data processing warehouse. This is all going to this big MLflow brick. So MLflow is a great tool which really empowers MLOps because it allows data scientists to train multiple models with multiple parameters set and keep track of metrics of these training sessions. And then if, for example, you have 10 sets of hyperparameters to test, then you are going to be able to pick the best one from the MLflow UI and put this model into production. So this is a really powerful tool and a tool that saves a lot of time and that's really user-friendly. So what MLflow needs is a web server which is hosted on App Engine, some artifacts. So it's going to be models, it's going to be graphs, it's going to be images are stored on cloud storage, and the logs, so the parameters, the performance indicators, etc., are going to our SQL database. At the end of this, we have the inference service that's going to be plugged into our artifact storage and allow Cloud Run to make inferences and to provide an endpoint to query models and to create the best models that we have and in production. So in order to deploy MLflow, we built a little open source tool which is called One-Click MLflow because we have developed a little maxim which is a model doesn't exist until it's in production. So we wanted to help our data scientists to be DevSecOps and MLOps proficient, but deploying MLOps tooling and especially the infrastructure, networking, and security side of things is kind of time consuming and not really what our data scientist friends like to do. So we've built a little tool that just terraforms MLflow on Google Cloud Platform. So this is going to set up the tracking server on App Engine. This is going to serve the Cloud SQL database. And this is going to set up the artifact buckets with all of the maximum security best practices. So we are building special networks, so no IPs exposed, etc. So this is going to package a lot of our knowledge and best practices into this one-liner, which is basically make one-click MLflow, and 30 minutes later you have a working MLflow ready to go on your project and ready to accept models and put them into production. This is an open source project. It still requires some work, so don't hesitate if you want to contribute or just check it out or use it and give us feedback. We will gladly incorporate changes, requests, and new features and bug fixes to the code. Finally, we need to provide value from our models. So our end users are demand planners, which are who are people who basically need to be able to see in the tool how many such and such perfume are going to be expected to be sold in the next few months. So for this, there's an app that's being built that's called the Launch Setter on App Engine, and of course it's secured with identity web proxy and uses the inference engine that we discussed earlier. So Cloud Run pulling models from cloud storage, so our famous MLflow artifacts, and using the data from our data mart, which is also the output from the data warehousing pipelines we also discussed earlier. So what are the takeaways? What did we learn from our serverless experience in this project? So the thing we like the most is to be able to quickly deliver features and show value. So we are team. We are 5 developers, and using this serverless architecture, once we build the foundation, allows us to have a very high speed of delivery. We also have a very high level of flexibility in the tooling. So some tools are interchangeable, and mostly this allows us to adapt to changing business needs, to new security requirements, etc. Scalability is almost a non-issue because most of the services that I talked about are scaled automatically by Google, with the exception of maybe Composer. So basically, we can serve 10 users or 10,000 users. And run-end maintenance should be way easier because of our documentation efforts, and also the fact that there's no software update to manage. There's no security. There's no security packages to update, etc. There's also limitations. It's not all perfect. We have to design the architecture around these specific services. So this tends to contradict some design models for architecture. And cost overruns, of course, are still possible. So you have to be really careful, for example, when using, for example, BigQuery, because you can run a query that is going to cost you hundreds or thousands of euros very easily. Also, maintaining such applications is kind of hard since of course, there's a shortage of cloud developers and they tend to be pretty expensive. And there's also some inevitable vendor locking. Because, for example, if you're using BigQuery, it's a pretty specific tool, and it's not easy to replicate it on AWS or Azure. There are similar tools, but they are not exactly the same. So you have to adapt your tooling a bit. So that's all for us. Thank you very much for your time. And of course, L'Oréal is hiring data developers, data engineers, software engineers, and we are too. So don't hesitate to chat with us.
Thank you, guys. Amazing presentation tonight. We have really the opportunity to have very valuable presentations from you and from Adrienne too. Just a quick reminder. I remind that you can still post some questions on the right part of the screen. Feel free to ask. It will be the opportunity to ask the questions to the speakers and to have some debate around these topics. So thank you, guys, and I think that we can move to the next and last part of the tonight's edition, which is a panel discussion. So we're gonna discuss things about the first talk and also continue discussions about what have been discussed in the second talk. To start, I saw some questions on the thread. I think we can start with a question for Adrienne, and we'll enlarge the discussion progressively, starting from there. So.
I have the question, Adrienne, if you want to.
I have it. That's okay.
Adrienne, somebody was asking during your presentation, you actually showed like some kind of dashboard, some kind of monitoring tool to get trace of the event sourcing of the orchestration. And someone was asking if this tool was kind of open source, how to use it, how to monitor your orchestrator using this kind of monitoring dashboard.
Yes. So what I showed that was explicitly showing each row of the queue messages as well as the orchestration events. That was actually the Azure Storage Explorer is what I showed in my demo. If you explicitly want to log the orchestrator, there's two ways I can think of. The first one is you can actually set the logging in your durable functions. I believe it's what is it called? It's one of the functions. I believe it's logging the replay events to be verbose. That way you do get the replay events in your logging. So that's one way in a quick pinch. The other way is another tool is actually a durable functions monitor. It's an open source project, and that one is actually much more helpful. So there's a GUI there that allows you to dive deeper into the orchestrator itself. And those are two very helpful tools for that.
Thank you, Adrienne. Apart from that, I had also one question of my own, if you don't mind, since we are talking about the, the durable function. How do you manage migration between workflows on the same durable function? Like, let's say in your example, if you have Lumpia recipe that is changing over time, and you actually have already some durable function instance running with a previous workflow, and you deploy a new workflow, how do you handle those two instances, these two models of workflow being deployed at the same time?
So there is a more complex way you can set those. There's something called sub-orchestrations, and you can infer. So if there is something that changes based on, say, a single parameter, you can keep the existing one, let's say the last steps that I've showed, as one sub-orchestration and make a determination to go with that workflow. Or if you have to migrate to a new one or have to keep both, you can now open another sub-orchestration. So it's just taking the subset of those steps and you can still place them within the orchestration. That's also one way to take workflows that are ballooning up and become larger and larger and larger. It's another way to kind of break them down again into manageable chunks. So for that specifically, obviously without knowing all the full details of what this migration looks like, I would say sub-orchestrations could work at the start.
Okay, thank you.
I saw a question regarding the amount of market shifting to durable functions. Do you see customers engaging on this technology at large scale, large projects today? Or is it so new?
I think a lot more are starting to try it very piecemeal. So for example, if they have some microservices where they're experiencing some of the problems that have been solved by durable functions, for example, the error handling, being able to see or lay out the steps in that single place. A lot of people are trying to migrate some of those particular workflows to durable functions. And I think some other people, the closest thing I think is the equivalent on AWS is actually step functions. So I see a lot more people using that. But once people find out that durable functions are fairly equivalent, I think a little bit better, then they do start to try it out. But I have seen it on like trading platforms where they're ingesting a large amount of like XML data that they have to process, or booking platforms, taking specific parts of like booking, those packages of the airplane ticket, the hotel, those types of pieces. I have seen people sharing them, but at least on a larger, more mainstream scale, not as of yet.
Okay.
I think we have some question on YouTube for you, Alexis. Somebody is asking, what is the cost impact of replicating data this much in the data warehouse?
It's actually not that expensive, all things considered, since storage is really cheap on BigQuery. It's mostly the processing that is going to be expensive, but you really have to. There are some caveats to avoid in terms of you can basically exponentially replicate data, which is going to cost you a lot very fast. So you have to be really careful with some end-type patterns that you can create. And honestly, if you're really careful and if you you manage your deployment correctly, usually it doesn't create problems. I'm not going to be able to give you orders of magnitude of what it costs for us, but basically you to query a terabyte of data, it costs you $5. So it's not that expensive, and moving data around is not that expensive either. You just have to be careful to not exponentially replicate it.
Okay, thank you, Alexis. I think I have another question for you. So what kind of Google App Engine are you using? Standard or flexible? And also...
we're using... Yeah, sorry.
No, that's okay. And also, what programming language do you use in this Google App Engine?
We're using App Engine Flex because we have this identity-aware requirement, and we want to move to Cloud Run. So basically, we're using App Engine Flex because it allows you to deploy Docker images in App Engine. And since we want to move to Cloud Run, which also takes Docker container as input, we chose this temporary solution. But I think we want to, at least for MLflow, move to Cloud Run as soon as EAP is made available to us by Google.
Okay, so it induced me of another question, because you want to use Cloud Run, and have you tested Kubeflow, for example, on top of Kubernetes, maybe?
No, we haven't, and it might be possibly because we can't do lots of Kubernetes, and we can't do like directly Kubernetes, but we can do managed services that are based on Kubernetes, such as Cloud Run, for example. But we didn't use Kubeflow because we didn't really have a need for it. Well, the tools we are using right now are really efficiently doing the job and are really easy to work with, so we are not using Kubeflow.
Okay.
I have a question, because I understand that you can't easily deal with Kubernetes, and you have to use much more abstract services using serverless functions and this kind of things. Using this kind of technologies generally implies to have much more lock-in, and so I was wondering what was the posture of your company toward this possible risk.
Well, it's really complicated to minimize vendor locking while also maximizing the use of not infrastructure as a service. Basically, we have to, I guess, maximize in our way of thinking and way of architecturing stuff the things that are portable to other clouds. So, for example, we just basically applied basic data warehousing principles, which are going to translate very well into other clouds environments. So this allows us to minimize vendor locking, but the technologies we use are really vendor specific. So this is there would be some work if we wanted to migrate to another cloud. But since L'Oréal has moved with Google like for about a year now, we are fairly confident that it's not going to be a really big issue anytime soon.
Is there some other questions?
At least on YouTube side, doesn't seem to have any more question. Maybe I have one of my own for you, Adrienne. I see that all of your orchestrator, so the whole workflow, is being rerun every time with the orchestrator. Is this actually completely abstracted from you, and you're not paying for this orchestration rerunning your workflow? Or is it something you have to take into account to make sure the processing time of the orchestrator is not that much of a big deal compared to the activity function processing?
Yes, so that's one of the main benefits that has been implied or portrayed in why you'd want to use durable functions. The stopping of it every time that it sends the queue message to the activity function, you are not getting charged because it is not running. It's not using resources. That's why we say to put all of the longer running things into activity functions, put all of the processing into activity functions, because there it's as you would expect. But for the orchestrator specifically, no, it does not charge as it is not running.
Does it have actually a maximum period of time that you can have an orchestrator leaving, or you're not limited at all on the total execution of the orchestrator, meaning the stop time and the active time?
That is a great question. There is a limit. I do not know what it is right now exactly. I can get back to you on that.
I have a general question, maybe more for Adrienne first, but it's open to everyone. A few years ago, I was thinking that orchestrators, orchestration of workflow, of tasks was something from the past. We were moving to more and more event-driven architectures and these kind of things. And finally, I see that products are getting more and more orchestration because there is still a lot of need for this. I see that durable function is pretty valuable already, but my question was, is there a chance or would be quite logical to imagine that we would shift to a more pure orchestration approach? I mean, having some acyclic graphs and this kind of things much more abstracted to have complete workflows, because I see that there are all the pieces to do real complex orchestration, but I see there is still needs to develop some parts or so my question was, is there a next step to have a much more global orchestration of serverless tasks?
I think they have been improving constantly, specifically to durable functions. So at this point, I think it's just the retraining of what models and what platforms and workflows we are using to actually go use the durable functions platform. What I see mostly is a lot of people who want to use the workflows, but don't necessarily want to go head deep first into, for example, Kubernetes, where every little part you need to know and understand and set. This is a good happy medium for those who need to set those pieces. So it can act as a good stepping stone to say if you need to go into more complex workflow orchestrations. I know they're not the same exact thing, but in terms of how people are migrating and evolving their platforms, that's something that we did. We were looking and saw, obviously, Kubernetes is the new shiny new thing. That doesn't mean you have to use it. And so something that we looked at first was using something like durable functions or even just the regular functions at first. But finding that medium of what works with your specific platform, I think, is where, at least in the developer networks I have seen, is where most people are. And so as far as that next step, it depends on the team and what is needed for their platform.
I have again one other question for you, Adrienne, related to limitation of the durable function. If you had only one wish to make about durable function, what would it be at the current stage of development of this service?
Can you explain a little further what your question means?
If there is one thing missing today for the durable function, what is it, in your own opinion?
I believe it was, so I just saw, it is one of the limitations for your last question, the durable timer that is used in a lot of the functions. So right now, the limitation is actually 7 days. And so that would be one thing that I would change, just because there are some other longer running things. For example, in the aggregator pattern that I've shown you, those can come over the span of months. There are ways to deal with that. But right now, for the durable timer specifically, where we use that to designate for example, how long to keep checking the monitor or keep checking the status in the monitor pattern, that limitation is 7 days right now. And then the other limitation that I found is the activity function. It does time out. So you have a timeout that a lot of people are getting upset at, because again, we always, at least the documentation on Microsoft advises to put any of the longer running things into activity functions. But even there are timeout values of, I think the last I checked was 10 or 20 minutes. So in that sense, they are still like regular functions. And with those functions, there are still time limitations for regular functions that we still need to keep in mind. So now reading that does remind me, that's probably one thing I would change, just because now that we are given this opportunity to create longer running workflows, sometimes some of those things really do take a long time. And so that's something that's been complained about often, is to have a little bit of a longer running time and not so short of a limitation.
Thank you. That's a nice wish. I think we're done. Any more questions, maybe?
Yes, there is. Arthur asked if a question for you, Adrienne, about durable function. How the durable function are priced? Is it based on duration, on amount of memories, stuff like that?
Yeah, so durable functions are billed the same as Azure Functions. So all of those same constraints still apply. When you execute the orchestrator function, it is billed based on the consumption plan.
Okay. So it's not a particular product, it's based on Azure Function, and it's totally free to use.
For the most part, yes. So those first free tiers, yes. And it makes sense since durable functions are an extension of Azure Functions. So most of the Azure Function limitations and billing apply to durable functions.
Okay, thank you. I don't think there is more questions. Maybe from your side, Frédéric, Adrien, Arthur, or Alexis, or even Christopher, if you have any questions.
The guy behind the scene.
Yeah, the guy switching layouts from the live.
So I think we're done. Yeah, maybe? Oh, okay. Well, so should anybody now have no longer questions raised? I think it's now time to tell goodbye, to thank warmly our tonight's speaker for these great talks. It was really interesting and valuable. I learned a lot of things. And I hope that people who attended the show discovered a lot of things as well. So thank you for our three tonight's speakers. I also want to thank all the organizers of this event, because it's a teamwork of a lot of people involved. And of course, last but not least, I would like to thank you to attend these events. It's not the same thing as real meetups and conferences, but I think we'll have some more time to spend for such events for the upcoming months. So keep on smiling, enjoy the talks, and hope to see you soon for the next events. Maybe someone wants to add the last words? Okay. So thank you. Have a nice evening. Thank you for
Thank you, everyone.
And
Thank you.
next time. Last thing. Do not forget to answer the form to give a feedback. So it's important for us to know how to enhance the event. And do not hesitate to post some conference talk proposals. So you can be the next speaker on the stage here. So please do not hesitate to contact here. You can see the links, and you'll be able to reach the stage and share us amazing things. Thank you so much. Have a nice evening.
One last word, Adrien. I will send you. I'm sorry. I will send you an email from the meetup with a link to propose new conferences, because it's a little bit complicated to type the URL. So I will send an email for the meetup.
Thank you all. Bye.
Thank you, everyone. Bye.
Thank you.